Alright, so today it's day 51. We're gonna continue, and the next problem we did the first 6. We skipped this one because we need premium in lead code, but maybe we do it later, I don't know. Now we're gonna continue with valid Sudoku. All of this should take a bit more because the difficulty it's increasing. Probably after this I'm gonna start doing like twice or 3 a day, I don't know, it depends. Also, maybe I should create like a local folder to run my... Oh no, okay, okay, yeah, maybe I should create like a local one, because if I need to run like things faster, I should be able to do it locally. So I think it's like this. I have already like a template. Wait, gh and repo create, and let's put it, what could be a name? Lead code okay. Okay, so I can run the code here locally. So this is the input. Let's copy the input. Okay. Alright, so let's read the problem, because I have not read it. It says valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Yep. Each column, okay, each row, each column, and each of the 9 3x3 sub-boxes of the grid must contain the digits 1 to 9 without repetition. I'm gonna do 1 hour and a half, so I'm gonna put a timer. Alright. So no row, no column, and no 3x3. That's it. I think this one should be easy, but it's very tricky. I mean, maybe the way I would do it, probably given a matrix, I would check all the rows, then I would check all the columns, and then I would check like all the squares. So I can create like a function, def, check rows. Okay, it's giving me the answer, come on. I gotta disable this for, I don't know, like 2 hours or something. Okay, so let's create check rows, and we passed the board, and here basically all the numbers from 1 to 9 without repetition. So what are the conditions? First, and it's 9 elements. Okay, so as long as they are unique, we can do the same trick. So the intuition would be, I'm gonna grab a row of the board. So for row in board, I'm gonna check if it's unique. Wait. Only the field cells. Okay, yeah, no. I was thinking about the solution if everything is already filled, because I can just take the row and compare it to the set of the list, and it should be different. I mean, it should be the same. If it's different, then it's invalid Sudoku. So we have to ignore the points. Maybe we can do we can store a variable that count the numbers that are not points. Yeah, I think that we should create a set called unique numbers, and it's an empty set. And then scene numbers. I think it's more scene numbers. And then for every row in board, if I have to check for every row, every number. Okay, but this is gonna be n square. Thus it says, okay, I should read more the thing. Okay, for sure it has to be everything n square, because we have to iterate over all the board. So I guess it's okay. Could be valid, but not necessarily solvable. Okay. Alright. And the length is always equal to 9. Okay. Let's do this then. So the intuition of the solution I want to implement, just to check in the rows, it's that I'm going to take a row, and then for each row, I'm going to look at the number. If it's not a point, I'm going to add it to the set, right? First, I'm going to check if it's in the set. Or maybe okay, doesn't matter. I'll check if it's in the set. If it's in the set, I increase the counter. Okay, yeah, I increase the counter and so on. If it's in the set, I increase the counter. And then I compare the size of the counter and the set. If it's different, it means that there is a duplicate. Okay, so it's gonna be for row in board. For every row in board, let's check for number. For num in row, we're gonna check if it's a point. If num equal a point, we're gonna skip. We're gonna continue. Else, we're gonna check if it's in the set. If num in scene numbers, then we're gonna we will always increase the counter. Yeah, so I'm complicating too much. Yeah, no, it's even easier. It's gonna be, we just have to increase the counter. We're gonna say scene numbers dot add num, and we're gonna increase the counter. Yeah, it should be the case. Because what we're doing here is that if the number is a dot, we're gonna skip. Otherwise, we're gonna add it and increase the counter. If it's duplicated, then the addition is not gonna match with the increase of the counter. So in the end, we're gonna return a boolean, which would be whether the length of the set is equal to the counter. And let's test it with this. Oh, wait. Yeah, wait, I'm tripping. Because we do this for every row. Wait, so the intuition is that if there is a false, if we do all iterations and we didn't find like something that is false, we return true. Otherwise, we should be able to return false. So let's try to make like a break in the for loop. So for every row in board, the counter is going to be set as 0 at each row, and the scene numbers are also at row level. Okay, and for every number in row, we do this, and then if we check after the row finishes, if this is different, we're gonna return false. And if it finished all the iterations, we're gonna return true. And I think we can now run this. And it's true, it's a valid board. Let's see. This one is a valid board, and let's pass the second board to see if it works also. And it still says true. So there is definitely a mistake. Or maybe because of the name or something. No, for sure there's a mistake. Oh, no, wait. Because we're checking all the rows yet. We gotta check now columns and then the squares. Number 2, it's the 5 in the top left corner being modified to 8. Yeah, the class is in a column. So let's implement the column. So first let's change, very easy, let's change this to 5 and this is false. Okay, so it's working. Now let's check columns. Check columns. I think that the best, like what I would do is just to transpose. I would transpose and then implement the same code. I don't know if I can use NumPy or Torch. Can I use NumPy in LeetCode? Let's see. Probably depends. I don't know, because if we can use NumPy, it's very easy. We'll transpose and do the same. All right, let's not use NumPy. So how I would check columns? To check columns, we're gonna get a row. Alright, let's see this image. What can we do to check all the columns? Maybe in the iterator, maybe here, because here it's for row in board, but I can do for I in range. And I can do it that this does this, and the iterator is in this way. Let's see if I can do this, like in some sort of way. So for E, for column in range, okay, let's put whatever. For I in range 3, print board 0 I. They should print like the range 9. So this is printing 5, 5, 7, 5, 3, 5, 3, 7. Okay, it's not working. It's the other way around, right? Okay, so in this way we get a single row. And if we do this for j in range 9, ij, in this way we're getting 5, 3. Okay, we just need to reverse this ji. In this way we get all the columns, and I think now it works. And this is more like a general code, so this is good. So now we can do the function check rows no, check columns. Okay, I don't know why did I wrote it again, but whatever. And also the good advantage is that we know that this number is fixed, but we can pass like the size of the board or something. But given they say it's fixed, if I remember correctly, they said it was 9 always, so it's alright. So we're gonna want to do the same scene numbers, and we did it before the second 4, so it should be here, and then we check. I mean, we're gonna have the same conditions, but instead of num, we're gonna have board, and we're gonna have j I, but everything is gonna be the same. And that's it. Pretty easy. That's nice. And we run the function. It's true. I'm gonna copy it again. I don't want to scroll. So let's say we change this one to 5. Now it's false. Okay, now it's working. Check columns, check rows. Both of them work. Now let's do a function to check the squares. Okay. But I think it's gonna be pretty similar. Let me think about it. Probably there is a way in which yeah, I think it's gonna be pretty similar, because I can say something like for I in range 9, but I can take steps of 3, I guess. No. Okay. It would be like for, because it's the first 3, or maybe I can even try to make it recursive. It could be like, monitor it here. Okay, let's spell it out just to see. We're gonna have board 0 0 0. Then we want to have this one with 1, then this one with 2, and then this is where it's gonna change. Now we want this one with 1, and then this one with 1 also, but this one 1, and this one 1 and 2, and this one 2 and 0, and so on. So the question is, how do I build this iterator? Let's see. For I in range, this is gonna be 1 block, and then the next one it's gonna go again and start at 0, board 0, but it's gonna be at 3rd position, and then this is gonna be at 4, and so on. So we can group this one into this. Right? So I can say okay. Let's try to build just the first block. The first block would be like for I in range starting from 0 going to 3, we're gonna take for j in range starting from 0 and going to, okay, what? 0 to 3, 0, 1, 2, 0, 1, 2, 0, 1, 2, and the other is also 0 to 3. Yeah. I'm gonna print, let's print just the indices, ij, first to see how it goes. So it's printing 0, 0, 0, 1, 0, 2, 1, 0. Okay, yeah, this is the normal word. But then at the next iteration, we want for this to be still the same, to run the same for loop. But the j we want it to be from 3 to 6. We want this. So now how can we do this? So essentially what we're saying is the first block is gonna be this, the second block is gonna be 0 plus 3, the third block is gonna be the third block. What is gonna be the third block? Is gonna be the previous one, also again plus 3, and then the fourth block, it's gonna be this one is gonna be 0 again, and this one should be plus 3. So now let's try to find a way to add this like dynamically, because I mean I could do this. Should I let this as it is, like define the 9 positions? I mean that's a solution. Actually, yeah, but I don't know, it looks very ugly. I think I'm gonna try to do it, to try to merge the code. Wait. This is really bad. So this is gonna be 0 to 3, 0 to 3. And then every time we run this, oh my god, I think it's unnecessarily complicated. I would use just numpy and that's it. So first I changed this one 3 times, 1, 2, 3. Then I restart and change the other one 1 and 3 times. So maybe I can say like for k in range because we're adding what I want is this one plus 3, then this one plus 6, and this one plus 9. So I would say that starts from 3, goes to 9, and has a step size of 3. I think this one could work. And then I would say like from 0, I think it's up to 6. Or I don't know, maybe up to 7. Because I think range doesn't take accounting to the last one. And then we should do plus k. Let's see if it works. So first is do 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2, 2, 0, and then 2, 1. I think this one should be inside this. Let's try again. 0, 1. Okay, definitely it doesn't go here also. Zero, 3, 0, 0, 0, 1, 0, 2, 0, 3. I'm thinking that maybe, and then it starts by 0, 3. So maybe the K. Okay, let's see what happens, just to test. So it's gonna be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, and then it's 3, 0, and it should be 0, 3. Yeah, definitely it's not here. I think it was right. Maybe I didn't read correctly. Let's see. Yeah, it was right. 0, 3, 0, 4, 0, 5, 1, 3, 1, 4, 1, 5, and then 2, 3, 2, 4, 2, 5, 0, 6, 0, 7, 0, 8. How many blocks? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's, yeah, 0, 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Okay, I'm lost with the indices again. So it's 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and then 0, 3, 0, 4. Okay. 0, 0, yeah, 9. So the first 3 blocks, 1, 2, 0, 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0. Okay, these first 3 blocks are the first big square. The next 3 blocks, 1, 2, 3, are the next square. The next 3 blocks. Okay, so I'm printing just the first row of the 3 blocks. Now I need to print. Yeah. I mean, the generalization seems like very. It looks very easy. We should do the same, but for another iterator, right? Let's call it ijk. What is the next iterator? Let's call it w. I don't know what's like a convention. This is plus w. And yeah, should be alright. Now, I mean, let's print board ij. And let's copy the board just to see it. This is the board, and this is the board. We are printing the board. So it's first 5.3 dot 6 dot dot 5.3 dot 6 dot 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 98. Okay, this is the first block, and then it's gonna be dot 7 dot 195 dot dot dot. It's gonna be like a lot of dots, then 6 dot. A lot of dots. What is this? Okay, I think there's a mistake probably. A lot of dots, but like so many dots. Okay, so let's see, 3, 9, 18, and it's gonna be 18 plus 9, 27. So it's gonna be 3, 6, 9, 3 dot 19 dot 19. Okay, I'm gonna see it here. I think it's better. So 195. I can identify it. And then there are like 3 dots, and then 3, 3, and then 3, 3, then the dot 6 dot, dot 6 dot, and then this important second step, the 8 dot dot, and it does it, 8 dot dot. Okay, so the code works. Now we have to do what we always do, which is create the set. We create the set, and basically we add the same logic, and I mean here is just the normal indices, and we can copy this into our function, check rows, check columns. I'm gonna call it check blocks, and I'm gonna return true. And even though we are seeing here that there are 4 loops, like this one skipped 3 elements, and this one also like the only 3 elements. So in theory, it's only like it's always square, like it's the same. Check blocks through, and let's change in the board that there is a 5 here in the 8, and it should output a false. It is outputting true, so there is an issue. What is the issue? Come on. For j in range I get it. Yeah, we have to do it at this level here, at the block level, because we're not working with rows or column now. So now should work. Perfect. And now if I remove I put the 8 back again, it should be true. Alright. So we're finished. I mean, now we need a function that that runs the 3 of them, and if any of these it's like false, then it returns false. Can I do like triple equality? I'm just curious. Does Python has triple equals? I mean, let's try it. I'm just curious. 1 equals 1 equals 1. True. And if I change one of them, it's false. Okay. So I can return check block words, check rows, check. It's gonna be check rows equal to check columns equal to check blocks, and this is gonna be the code. So I'm gonna run it. Check rows. We make sure the indent it's okay. Check columns, and then check blocks. The indentation, and then return this, and should be alright. Okay, there is an issue. Okay, I think that maybe this has to be one more, and this one also one more. Although I don't know at which level to put the functions. But if they're inside the main function, I guess it's okay. Wrong answer. Come on. For 471 test cases, it passed. What would be a test case in which it failed? it's gonna be this test case. Let's see why it's failing. I mean, it should output. Why it's outputting true? Come on, it's outputting true, and obviously there is a 5 here, so the check blocks should not run. Let's see. Board equal to this. Run all. Yeah, and it's outputting true. But check blocks it false. Maybe because all of them are false. Okay. Yeah, if the 3 of them are false, then this is gonna output true. Right? Let's see. False equal false equal false. And it's true. So how can I fix it? I mean, one way is like to create like a simple if or something. Maybe a XOR. Yeah, and XOR makes sense because it's gonna be. No, XOR doesn't make sense. I just want to say if any of this is false, output false. Otherwise, output true. Okay, let's just use the simple logic. If this or this or this, if this equal false or this equal false or this equal false, return false, else return true. And we're gonna do this, and we run it, and we submit. Yeah, but this mistake, it's like okay, an error again. Is it the same? I don't know if it's the same error. Okay, let's look quickly at the board. What is the output? I'm outputting true and it should be false. Okay, I didn't think about this, the edge case in which all of them are skipped, but I guess it doesn't matter. Or does it? Because if everything gets skipped, yeah, it's considered a valid Sudoku, right? So in this case, in the blocks, I think that the blocks are fine. Oh no, this block is not fine. So at least by the blocks checking, it should be false, and it's outputting true. 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. This block is not recognizing it as false, and I don't get why. What could it be the case? Let's see. No, it's okay. The code is okay. If length in numbers is different than counter. So what's the issue? Let's print scene numbers. Yeah, because I don't get why it's not working. What? It's 1 2. So it's doing set yeah, then the next iteration is not set. Oh no, yeah, it is set. And then there is the 5, right? But then the next iteration, what happened to the next iteration? It was working. Like, I swear it was working. The next iteration should output the 9. It was outputting the 9. So this is set. And we do it for W, for K, for W, and for K. So we do this. We do the set. Ta 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 ta. Maybe it's not even working for. Yeah, maybe there's an error. I mean, this block is not getting until the block 8 dot dot 4 dot dot. But it was. I'm pretty sure it was in that block. Five, 3. Yeah, it's not getting. It's just getting up to this block. Oh my god. Oh, this hurts. It was just the return. The return value was just. Yeah, it was that. Come on. These type of mistakes are really. These types of mistake really suck. I'm pretty sure it was that. Let's print the blocks. Yeah, now it's working. Oh my god, it was that? There was an error here, an indentation error. I don't know what happened. Maybe when I copy and paste the code, I moved the indentation or something. Okay. And alright. Let's see the solutions. So let's see a Python one. This one has high. It's saying, okay, with functions also, and it looks very easy. So first let's check, is it valid, like with the function? Okay, I knew I could use something. Yeah, you can use pure ends. Okay. Alright. And then he created, what is this? Self.isSquare valid? He's creating, because the validator is a class. The solution is a class. So this is an attribute, and it's calling the function as an attribute. And then it says def is row valid. If row is valid, for row import, if not, self.is unit valid. What is unit valid? Unit do I for I in unit if I different than point. So basically it checks every element and do exactly what I did. Okay, check the the sizes of the original unit. Okay, it's more atomic, it's nicer, but this one, it's the same. And then for columns, it's using zip. So it's doing for column in zip board. Oh, so this is like the, oh, I didn't know. So this is like the transpose. Okay, now I know. Now I know. Okay. And what is this? Is a square valid for I and for j goes from 0 to 3 and a step of 6. He's doing, and then another 2 for loops inside. So the square is definitely for, I think I did the same. I mean, he did it more like with least comprehension, but it's from 0 plus something in both of the loops, and it's here plus something for x in range I comma I plus 3, and then for j in range j to j plus 3. But what he's doing is that he has the fixed I and j. He has a fixed I and j that goes from 0 to 3 and then to 6. 0, 3, 0, 1, 2. I mean, it doesn't make sense. Why would the step size be of 6? It would be only 0 and 3. Okay, I think it's alright. I like actually my solution even more, but it's okay. We finished valid Sudoku. Let's do the next one. Longest consecutive sequence given an unsorted longest. What is this one? Yeah, maybe I should put just the number 128.5 Okay, it says given an unsorted array of integer nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O(n) time. So we have a list of numbers and the output is 4, and the explanation is the longest consecutive element sequence is 1, 2, 3, 4, therefore its length is 4. 1, 2, 3, 4. Okay. How would I do it? The thing is, like, the sequence could be everything. And how long are the numbers? I don't know if you can store like a big array, 10 to the 5. Okay, I have one solution, but it says here it should run on O(n) time. One like easy solution should be like sort this, and then have a pointer that starts at the first element and iterates the next one. If the next one is consecutive, like if you increase by 1 and it's still and the pointer still matches with the number, with the value, you continue, right? And if the length is still like bigger than the max, you replace the max by those by the number, by the current value of the max sequence. But if the next one is different, you have to break and restart the current length as 0. That would be the n log n solution. I'm gonna do it. Just I think it's for good practice. So we have the nums, and we can do like nums sorted. It would be sorted nums. And once they are sorted, what we can do is iterate for e in range length nums sorted. Wait, we're gonna take the value. Okay, we need the current, which is gonna be 0, the current, which is 0, and the max sequence length, which is gonna be also 0. And then we can start by at 1, yeah, and then we can say if nums sorted I is equal to this one minus 1. So basically here I'm saying is I'm gonna start at this element and I'm gonna compare it with the previous one. If this one plus 1, so it's consecutive with the previous one, if it's consecutive, then I'm gonna increase the current by 1, and then else the current is gonna be again at 0. And I kinda have to check also always if current is bigger than max, then max is gonna be equal to current. I think that would be a solution. And we gotta print, let's do it in another column. We're gonna print max sequence length. We run, so it's 0, so there is an error. What could be the error? Okay, let's see. Nums sorted I, so it's gonna start at the 1, and it's gonna say this one plus 1. Okay, definitely it's not this one plus 1. I don't know why I put the condition here. It's this one plus 1, the previous plus 1, or the first one minus 1, whatever. Okay, so the max sequence length is 3. Yeah, I think that we can always start by 1, although I don't know if we can receive like an empty, if nums it's gonna be empty. I think I'm gonna assume it's not empty. If it's empty, I can add just a condition that if it's empty, return 0, otherwise do this. So yeah, return max should work. Okay, there is a problem. Num sorted doesn't exist. Submit. I'm gonna put it because it's part of the code. And there's a error. Yeah. If it's empty, I'm saying 1. If nums, if not nums, return 0. Okay, there's still an error. I'm receiving 2 I'm receiving 1, 2, 6, 7, 8. So this is already order. And then I'm saying, I don't know why it's 4. Okay, this is with the previous one. I start with by 1. I compare these two. It checks out. The currents increase, so now it's 2. Now the max length sequence is also 2. Maybe because of this. My god. I don't know why did I add that and forgot to remove it. Still wrong answer. So I have, wait, the max sequence length, it's 1. Oh, it should be 0, 1, 2, 3, 4, 5, 6, 7, 8. Why it's 1? Let's see. So I start at 1. Okay, I don't know why I put 0. Should be 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay, small mistakes. Another error. Let's see, what is the error? 0, 1, 1, 2. I'm outputting 2, and it's 2. 0 and 1, and 1 and 2. Expected 3. Wait. Yeah, I can do 0, 1, 2. Yeah, no, definitely. This is some important edge case. I don't know why I didn't consider this edge case. I can say that if these are equal, just continue. We're gonna just skip. I think this should solve it. Yeah, but that was an important edge case I didn't consider. All right. What? Still the same error? I'm not getting that error. No, it's a different error. I'm outputting 2, and it should be 3. 6, 7, 8. Yeah, it should be 6, 7, 8. So I compare these two. So here we never do this because there are no elements that are the same. We compare the two precedents, and now current is 2. Now we update max sequence length to 2, and then we compare the next one. We compare the next one. Maybe because of how this is done. Yeah, I don't like this if else, but okay. We compare the next one. 2. We undo this because this was true. We go now for the next iteration. We got the 6. There's definitely not the same, and there's definitely not consecutive. But it's definitely not consecutive. And then it's checking if the current is greater than max sequence length, which is false. So now curve should be 1. Let's print curve just to check if it's doing what it's supposed to do. So first it's 1, then enters here, it's 2. Next iteration is 1, the 6, when with the 7, why it's 1 again? 1, 2 is 2, right? 1, 2 is 1. No, 1 first start it's 1, then 1, 2. updates to 2, but at the end of the iteration, so it's not yet printed. But now, and this one is updated, core it's still 2, now we print the 2, and then no sorted I, this is, we don't enter this condition, and then we definitely not enter this condition. And then if the current greater than max sequence length, which is not true, we set up this at 1, and then we print this at 1, which is correct. But then this one should increase the current. But the problem is that the problem is that given that this condition is not true, it's a resetting curve. I think it's better to have equal, and in this way we are saying that we're gonna say that the current sequence length is the promising one. But now we have 4. 1, 2, 3. And it should be 3. So it's 1, 2, but it's the same and it's not cutting in this one. Should be, because it's 1, then it finishes is 2, it starts again, prints it is 2, is 2. If it's equal, maybe what I can do is like, I'm gonna improve the logic here. If they are the same, skip. If they are not consecutive, instead of saying if they are consecutive, increase current, maybe I can say if they are not consecutive, reset current. Reset current. Okay, I don't want to break all the code, so I'm just gonna create it again here. Comment this one. The current, it's gonna be resetted if they're not consecutive. So if they're not consecutive, we can just reset. Otherwise, they're gonna be consecutive. If they are consecutive, we want to increase curve by 1, and if the current is greater or equal to the max length, we update. Okay, it's working now. I don't know if it will work, but let's try it. Okay, the empty case. What was the empty case? How did we deal with the empty case? I forgot. It was if not num, nums return 0. Submit. Okay, it's pretty bad, the algorithm. Why? Because they said do it in ON log n. Alright, now let's think about it. How can we do it in O of n time? Let's see. Let's delete this. Let's comment this. How can we do it in O of n time? So like we cannot sort the array. Maybe we can kind of create like a hash map. Maybe. Okay, let's try to think about it. If we create a hash map, how could it be? We would have like 100, and then we're gonna add it can either try to find 99 or 101. Then we're gonna have 4 and the value, no, but it's not O of n. But maybe I think it's not a bad idea. I'm thinking of creating like a set that adds up and down, and in the next iteration, in the next number, it's gonna search if it's in the set, and it's gonna add its number up and down, and then it's gonna check if it's in the set. No, but or yes, does it work? But then how are you gonna count? 4, it's gonna search 3 and 2. You're gonna say 100, and there you're gonna search. You're gonna add. Okay, so the iteration would be like you're gonna have the set, and it's gonna be empty. You encounter the 100, and you're gonna add 99 and 101. And then next iteration, you have the 4, and then the max. You have also the current, which is 1, and the max, which is also 1. And after seeing the first one, we didn't change. We have this, right? Then we get to the 4, and we ask, is 3 or 5 in the set? No. So we are gonna add them, 3 and 5. And then we're gonna check 200, and then is 999 and 201 in the set? No. We add them. Then we have 1. We ask, is 0 or 2 in the set? No. So we add 0 and 2. And then we have 3. Oh, I have to check if the number itself is in the set. And then if not, I'm gonna add the adjacent numbers. Yeah, that's like the intuition. 99, yeah, maybe if I missed something. 99, 101, let's do it again. 4 is not, but we add 3 and 5. 200 is not, but we add these 2. And then 1 is not, but we add 0 and 2. Okay, it's right. And then 3, it is in the set. So 3, it's in the set. So maybe without current. So the max, it's gonna be now 2. And we add, if 3 is in the set, it means that there was another number. But I don't know like how, we don't know how big the sequence is. because we added 3 and 5 because there was a 4, and then now that we find the 3, the sequence is 3, 4. Yeah, now that we find the 3, the sequence is 3, 4, and I should add 2 and 4. And if I add 2 and 4, 2 it's already also in the set. Yeah, how? So if it's already in the set, I have to have a way to store what is pointing to what. Let's see. It's gonna be 1, 2, 3, 4. 99. Wait. Yeah, all my ideas are not O of n. All my ideas, none of them are O of n. We can do 1, then add 2, then add. Okay, let's do one of these. We add 100, then we add 4, then we add 200, then we add 1, then we add 3. You're gonna say 3 is connected to 4, so we're gonna add. We can say we're gonna add 3 is connected to 4, so we check in the dictionary. So instead of using a set, I can use a dictionary, and when I check if 3 it's in 4, to 4 I add 1, so everyone starts at 0. To 4 I add 1, and to 4 I add 1, and to 3 I put also 1, or I don't even need to put 1, or do I? Yeah, I think it's better if I also put 1. To 3 I also put 1, and I go 2, I check the 3, the value it has, and the value of 3 it's gonna be 1, so I'm gonna add 1. Yeah, I think that's the case, and it's gonna be O of 3n, something like this, so it's gonna be still O of n. I think this is a nice solution. Yeah, it should work. Let's try to implement it. It's gonna be we start like by a dictionary, dict noms, let's call it, and we are, let's say that we start by saying that let's use the collection from collections, import counter, and then I say something like dict noms equals noms. Okay, this is not what I want. What I want is just a simple dictionary that starts all the noms with 0. But it's okay, I can make them on the fly. I think it's better like this. So dict noms, it's gonna be empty. Then for for num in nums, if we are gonna check if dignums, I think I need this condition, because if it's empty there is an error, I believe. I mean, let's try it out because I don't remember. Dignums of num equal, let's say that we are asking if it's equal, I don't know, to some value. I think this should be an error. Print no error. Yeah, there is an error because the key doesn't exist. But if I do this, I think I need get the get key name value dict nums dot get, the key name is gonna be num and the value it's gonna be 1. If it doesn't exist, it's gonna be 1. Should this work? Okay. So I can say dict nums of nums is gonna be equal okay, I probably need a break. I'm not thinking straight anymore. The intuition is very simple. We're gonna have this list, we're gonna iterate over the list, we're gonna, if the number is not in the dictionary, we're gonna add it, right? So we can say dict nums, first we initialize the number okay, let's go again, overview. I'm gonna get the 0, and then I'm gonna add it to the dictionary as 0, 1, like this. I want to have 0, 1, and then I'm gonna go with a 3, and I'm gonna say like, I'm gonna add, first I gotta check if, I check if 2 and 4 are in the dictionary. If they are in the dictionary, I'm gonna add 1 to 2 and 4. But maybe I'm adding it as a duplicate. Or maybe I'm not duplicating it, because if I had 2 and 4 before, and then I find the 3, 2 and 4 are both gonna have 1, and once I have the 3, I'm saying like, first I search 2, it's 2, then I'm gonna add 1 to 2, right? I'm gonna add 1 to 2, so 2, it has 2. Now 3 has 2 also. And then I'm gonna check 4. 4 it is. So I should add to 4, I should add 2. So it's gonna have 3, but then the 2 is not correctly updated. Yeah, the 2 is gonna have 2 instead of 4. What could be the solution? The solution could be, I'm gonna check if 2 it is, and if 4 if it is. If only 2 it is, I add one element to 2 and the current number to the dictionary. If only 4, I do it to 4 and the current. If both of them, I add two numbers to the current, to the 3 of them. Yeah, I can divide it in cases. Okay. So first, I gotta check if num in dignums. If num, I have to check first if num -1 in dignums. So I have the, let's say we are a little bit far in the iteration. We're checking, let's say we're doing this and we are at this position 1, checking if 0 and 2 is in the iteration. No. And then I go to 3. Okay, I'm in this position. Let's say I'm gonna check if 2 is in the iteration, if num -1 is in the if num -1 is in dignums, it means that nums -1 is in dignums. There's a sequence. I gotta add 1 dignums num -1 I gotta update, but not yet. Okay, let's forget about the triple case. Let's just do this one first. If the previous one, if a number -1, it's in the dictionary, then we're gonna add one value, right? And otherwise, I'm gonna check if num. Okay, I'm gonna check the same, but for num +1, I'm gonna add one value, and then I gotta check so 1 is in the dictionary, 1 + 1, 3 is in the dictionary, and +1, and then I gotta add in the dictionary of num I know how to fix it. I can say dignums of num is also +1, then but not necessarily. This one is also +1. If I check the previous one and it was in nums, I'm adding +1, +1, also +1, +1, and I also kind of want to say that oh my god, I don't know why it's taking me so long. I cannot think anymore. 100, 2, I'm checking 2 - 1 = 1. This is also = 1. Let's do this sequence. So first we're gonna have 0 as 1, then we're gonna have 3, and we're gonna say this is not the case, right? So we're just gonna add 3, 1. Then we're gonna go at 7. right? And then I'm gonna put 7 1. Then I'm gonna go at 2, and we're gonna say there's a 3. So we're gonna enter in the first condition. So 3 is gonna be plus 1, and then 2 is gonna be 2 also, right? That's because there is a 3. But what if I start receiving like duplicate numbers? I think this is gonna break the program. Okay, I can handle duplicates, maybe. Because because I'm checking adjacency. If I check if it's in the dictionary, I can skip. Okay, so I'm gonna have 0 3 7 2. We find that 0 3 7, then we go by 2, and we say, hey, 2 is connected with 3. So 3 and 2 we update, and then we go 5, we put 5 1, then we go 8, we put 8 1, and then we put 4, and we say, you know what, 3 is in the dictionary, and also 5. So first we go to 3 and add plus 1. And I think that I can put this one like this. Now 4 has also 3, but now it searched that 5 it's also in the dictionary. So maybe I have to add these nums. Yeah, where's 5? I'm gonna add 3, so it's gonna be 4, and then this is gonna be 4 also, and then I'm gonna check 6, and it's gonna say, you know what, 5 it's already. So given that 5 is already in 5, I'm gonna put in 4, in 5 I'm gonna put 5, in 6 I'm gonna put 5, and then checks if 7 it is, and 7 it is. So I'm gonna put yeah, so to this one I add 5, so it has 6, and to this one I put 6, and then I look at 0, there is no -1, and there is no 1, and then I go with 1, and then I go with 1, and 1 is gonna be, I have 0, so now the 0 is 7, 0 should be 7, this one is gonna be 7, and then I check for 2, this is gonna be 9, and the max sequence is 9. Which is 1 2 3 4 5 6 7 8 9. But I think it is not correct, because, or is it? I don't know if it's correct, because our values are not updated. Yeah, there are values that are not updated, but in the end I can iterate over them and get the max. Okay, let's try it, and then we are gonna debug and everything. So lit nums. So I start with 0 1. nums, dict nums, dict nums, dict nums, it's empty, and dict nums 1, let's say 0, is equal to dict nums. Let's just make sure we don't get like any errors. Get 0, 0. There is no error. That's good. Okay. So I can do this. So yeah, I can do dict nums. I can do this. Dict nums num is this one. So it's this value, right? So basically, it's if it doesn't exist, it initializes 1. Okay, and it's this one, the 0. And then check two conditions, like the adjacency. I'm gonna put check adjacency. I'm gonna check adjacency. If there is no adjacency, there's already a 1, so it's fine. And in the next iteration, it's gonna do for 3, it's gonna do also 1, and then for 7, it's gonna do also 1, and then for 2, then there is adjacency. So first check if there is 1 minus, no. Then checks if there is 1 plus, yes. So if there is 1 plus, which is the 3, we're gonna take the 3, dict nums plus I, and we're gonna update it. We're gonna add dict nums num, which is gonna be 1. So 3 is gonna have 2. And we're gonna update the value of 2 also to 2. And then we're gonna go to 5. 5, there is no 4 or 6. Then we go to 8. Then we go to 8. Checks if there is a 7. There is a 7. So I'm gonna add this one, dict num num. Wait, checks a 7. Then to 7 I add 1. I'm gonna have 2, and to 8 I add the I add it as the previous one, so it's gonna have 2. And then I'm gonna go, there's a 9, there's no 9, we continue, then we search for the 4, and then there's a 3, so I go here and do plus 1, so we have 3, and then 4, we assign it as 3. Then we get to the other condition, is there a 5? Yes, there is a 5, so we add 3, so this is gonna have 4, and we set this as 4, and then that's it. Then we're gonna check that 6, and there is a 5, so we're gonna add 1, we're gonna have 5, and then 6, it's gonna ask if there's a 7. Yeah, there is a 7, and it has 2, so I'm gonna add 5, so now 7 has 7, and 6 is 7, and then I'm gonna go at 0. There is no minus 1, but there is a 1, there is no 1. I'm gonna go at 0. If I got at 0 again, I would update Okay, I'm gonna add a 0 at the end just to see what happens. So in this case, nothing happens. I'm gonna go at 0, check at -1, nothing, check at 1, nothing, skip. And there is already a 0 at 1. Then we go at 1, and there is no 1, so I'm gonna initialize at 1. We check, there is a 0, so now this is gonna be +1, and this is gonna be also 2. Then we check a 2, and the 2 has a 2, so I'm gonna add +2 to make it a 4. The 2 has +2, so now it's a 4. Yeah, there's a mistake. And then this is 4. And I think that's a mistake. Yeah, that's a mistake. How can I fix it? How can I fix it? The information of 0 has to be passed to the... I mean, the intuition is that the 0, we don't need the 0 because the information is going to be in the adjacent numbers. So I don't know if I made the algorithm wrong in one step. I have 6. 6 and 7 both have 7. But 7 is not the greatest sequence. Then I check 0. Yeah, it's not working. Okay, let's try to solve it. I think this is promising. 0, 2. So the issue is that we're gonna update back the other number. So it's gonna be 0, 1, then 3, 1, then 7, 1, then 2. And then the question is like, you know what? There is 3. So in 3, I'm gonna put 2, and in 2, I'm gonna put 2. That's it. Then 5, there is no 4, no 6. Then we got at 8, there's a 7, 8, there's a 7, so we're gonna put 2 and 2, and then there's a 4, the 3, we add 1, the 4, we add 1, and then we search a 5, there's a 5, and here is where the algorithm should work. I'm gonna add 3, so 5 is 4, and then 3 should also be 4, and 4 should also be 4, and then 5, why 4? Ah yeah, 4, then let's select 6, we search for 5, so 5 is gonna be 5, and then let's search for 7, 7 is 2, so 7, 2 is gonna be 7, 6 is gonna be 7, and 5 is gonna be 7, and then 0, and 0 it's gonna be 0, it's gonna be I mean 0, it's already there. Then we check 1, and 1, there's a 0, which is a 1, we put 2, and then we check for a 2, which is 2, we add 2, which is 4, we can even add to 0, 4, but that does not fix it. Zero, 1, 2, 3, and 4 are connected. 0, 1, 2, 3, and 4. But 5, the connection loses on 5. Because 4 doesn't exist yet. 4. Oh, no, bro, I'm tripping. I think I'm definitely tripping. I did it wrong entirely. I think the algorithm in fact works. 0, 1, 3, 1, 7, 1, 2, 1, 1, no. Then it's 3, 2, and 2, 2, 3, 2, 2, 2, then 5. There is no 4, no 6. Then 8. Is there a 7? There is a 7. Is there a 9? There is no 9. We go to 4. Is there a 3? Yes, there's a 3. So we add 3. There's a 5. Yeah, there is a 5. This is 4, and this is 4. And then we go to 6. Is there a 5? There's a 5, yes, 4. We put 5. Is there a 7? Yes, we put 7. No, I think I have the same problem. 0. Okay, 0, 1, 3, 1, 7, 1, 2. We have to say 3 is 2 and 2 is 2. 2 is 2. Because there's 3, there is no 1. And then 5, 5 for 4. There's no 4 for 6, there is no 6. Then 8. There's a 7. And we put in the 7, we put 2. And then there's a 9. There's no 9. Then we go to 4. There are 5. Yes, there is a 5. No, there's a 3 for the 3. So in the 3 we put 3. In the 5 we put 4 and we apply the 3 and the 4. Then we go to 6, and in the 6 we ask there is a 5 and we say yes, so we put a 5 and a 5. Then we check a 7, there is a 7, so we put 7, 7, 7, and then 0, and then 1, and then this is 2, and this is 2. And then for 1, and then I check 2, 2 is 2, so it's gonna be 4, is 4, and 0 is 4, but they are disconnected. They are disconnected. The 2, 3, the 4, 5, 6, 7, the 8, zero, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there are 9 numbers. Means the connection between why this 8 does not register the 7, because in the iteration of the 7 still has not what it wants. Okay, I think at this point it's better to just look at the answer, because I think I'm taking so long. Let's see the answer. Sorting, yes, and then this one, hash set. Okay, at least the intuition was right. It was like with hash sets. Let's try to understand the code. Okay, so we make set of nums, right? We define longest, and then we check for num in nums. Does they explain? No, they don't explain, right? We need to find the longest consecutive subsequence in linear time. We can do this if we insert all the elements of nums into hash sets. Once we have inserted all the elements, we can just iterate over the hash set to find the longest consecutive sequence involving the current element. That can simply be done by iterating over elements that are consecutive to num till we keep defining. Okay, so it's like the other one, so it's even easier, right? Because we're gonna do, okay, we're gonna do for num in nums as intuition. Now I know that I cannot take too much time. Think of other solutions always before coding. Like don't fix on an idea, explore more abstract before code. Yeah, because in this one I don't know, like the solution is very easy, but I don't know, I wasn't able to come up with it because I was fixed in my specific solution. All right, so for num in nums, cur longest j equal 1, 1. Okay, and then while num minus j in s dot remove so the current longest is going to be 1 along with j, and then I'm going to subtract num minus j in s. I'm going to check if there is the previous element, if it's in the hash. I'm going to remove it from the set and I'm gonna make the current longest. Is this O of n, really? Because we are, the set as is smaller. Okay, so the current longest, we're gonna increase it by 1 along with j, right? And while, so for example, we do nums, right? We print nums, and we print set nums, and then we go here and say, let's look at the first element, which is this. Let's look at the first element, which is the 0, and let's search it. Let's search 0 minus 1 in S, which there is none, and we search then 3 minus 1 in S, which is going to be 2. And then we remove 2 from nums, but then we're going to add plus 1 to j and the current. So now we are going to search for 1 in the set, we're going to remove it, then we're going to search for 0 and we're going to remove it, so this is 3 elements, and then the current longest is 3. It does also this in the same loop. Let's see. So first the 0, it searched for minus 1, doesn't find it. Then it searched for 1 in the set. There is a 1. If there is a 1, I increase j. So I have this and I have this set. We start by 0. We find there is no 1, no minus 1, so we don't enter this condition. Then there is a 1 in the set, so we remove the 1 in the set, and we say that longest is equal to 1 to 2, right? Also a j. And what else? And then we say longest is the man between the longest and the current longest. Okay, then we go current longest, it's gonna be again 1, and we're gonna check now the 3, and then here we check there is a 2, right? So we remove the 2, update the current as 2, update the current longest as 2, okay. Then we search for 4, we find 4, remove, I know, but it's, no, it's building, no, because it's a while, it's just not one iteration, it's a while. So it's gonna be 0, now it doesn't find it, then it's gonna go to the right, and it's gonna go 0, 1, 2, 3, 4, 5, 6, 7, 8, and it's gonna stop, and it's gonna say this is the max current. Oh my god, this is very, 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 very easy. Oh my god. I think, I don't know why I didn't come up with this. Alright, I will try to implement it myself. So we're gonna have nums, I'm gonna remove this, I'm gonna pass this up below, let's try to redo it. So it's gonna be nums, it's a list of numbers, and we're gonna say we're gonna create a dictionary. Dignums, is it defined above? No, nothing, it's okay. And we're gonna say dignums is equal to a set. Okay, so we create a set of noms, and then we check for nom in noms. We're gonna check to the thing is, like, you're checking all the way to the left and all the way to the right. So if you have 0 and you have -1 and -2, 0, you're gonna remove -1 and -2 from the set, but it's 0 on the set. Yeah, for sure, it has to be on the set. So I don't need to remove it. I'm gonna remove -1. But the intuition is that the set is gonna get smaller. Once I encounter -2, there will be nothing in the set. So I need to add them, right? I have to the current, it's still the current. Okay, makes sense. So let's try to do it. For num in noms, we're gonna check to the left while num, okay, we need like a pointer. We're gonna say like the current longest, it's gonna be equal to 1, and we're gonna define the iterator here as 1 also, and I'm gonna say while num minus iterator in dignums, there is one place to the left. I gotta increase current longest and iterator. Okay, and while I can go to the left, I'm gonna increase it. Okay, I gotta remove it also, so I'm gonna say dignums dot remove num minus iterator. I'm gonna go to the left, remove it, so on, iterator, and then I'm gonna say iterator equal to 1 again. And the current longest capture already the sequence to the left, and I'm gonna capture the sequence to the right plus 1, and this is plus the iterator, and then I'm gonna say max what is the max longest? I'm gonna say it's equal to 1. I'm gonna say that longest is equal to the max between the longest and the current longest. Then the current longest is gonna be 1 again. Okay, then I'm gonna print longest 9. Okay, I think it works now. Let's try it. And return Wrong answer. Okay, I didn't check if it's empty. If nums return 0. Okay, it's very slow. What? It is very, 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 very slow. I thought it was faster. Bro. I'm gonna ask ChatGPT. I implemented 2 solutions. Is the first one, because it involves sorting, it is n log n. Is the second O of n, or is it slower? Come on. They do it like this. And they say here that it's O of n. But it doesn't have optimizations, maybe because of that. We can form a solution without the need to spend time erasing elements from the hash set. Instead of taking the first element that we find in the hash set, iterating both forward and backward, we can just skipping till we find that the hash set contains num minus 1. This is very smart. Don't think about it, because we are finding the root. Once you find like the first element, the root, if there is nothing to the left, it means that you have not found the beginning of the sequence. Once you find the beginning of the sequence, you iterate over the right. Yeah, makes a lot of sense. Yeah, makes a lot of sense. I'm gonna comment it. I don't know why did I even do this one, if it's really bad. Let's see this one. So this one is start S and longest, yes. And then for every number in S, if num minus 1 in S, continue. So if it's the root, we're gonna start. If there is a root, j is equal to 1, and then while num plus j in S, j plus 1, j plus equal 1, yeah, you just iterate. Oh my god, this is very pretty. So I'm gonna say mark them. We traverse all numbers until we find but wait, this is not a guarantee that it's the root, because it's only that it has 1 before. If it has 1 before, oh yeah, no, it guarantees that it has a root, because if it has 1 before, it's gonna skip. If it doesn't has 1 before, it's gonna iterate until, okay, yeah, we traverse all the numbers until we find the root. There is no predecessor. Then we iterate forward while saving the length of the sequence. That's it. Yeah, makes a lot of sense. Oh, I didn't put the return. And here we can say directly start with 0, because if it's empty, it's gonna return 0. And if not, j is gonna be equal to 1, and it's gonna start by 1. Okay, whatever. Okay, I'm gonna take a break.